Raw Detail, launched in 2019 as Enhanced Detail, was the first feature to use a convolutional neural network for demosecing raw files, with the aim of ensuring better quality with the same computational resources. The same approach was then used for the super resolution feature, which aims to enlarge an image quadrupling the number of original pixels while maintaining sharp, well-defined profiles. In this case, the neural network was trained using a set of low and high resolution image pairs to teach the network how to perform upscaling. The AI features use Apple and Microsoft's machine learning platforms and require Mac OS 10.14 or later, or Windows 10 1903 or later. Raw Detail cannot use twice, and can only be used on raw images produced by Bayer and X-trans sensors. Raw images produced by other types of sensors, low-resolution RAW, black and white RAW, and any non-RAW formats are not supported. Super resolution, on the other hand, can also be used with TIFF and JPEG files. The functions can be accessed from the Photo Enhance menu or from the context menu by right-clicking and selecting Enhance. Alternatively, they can be accessed from the Detail panel by clicking on Denoise. Denoise is also part of the AI functions and uses the same interface. They are very easy to use. You can apply only raw detail or only super resolution. But if the source file is a raw, super resolution, will automatically enable raw detail as well. Denoise and raw detail super resolution, on the other hand, are mutually exclusive. Clicking on the Enhance button will create a copy of the original file in DNG format. By checking the Create Stack checkbox, the copy will be stacked with the original. By holding down Alt or Option when clicking on Enhance, the dialog box will not appear and the last selected enhancement will be applied. As with Denoise, when you click inside the preview window, the enhancement effect is suspended, so the click acts as a before or after comparison. All the enhanced images will have a badge in grid and film strip views. And in the History tab, left column, a history step with a timestamp will be created. How do they work? Let's start with some objective data. Here are the results of an MTF test on a file from an old 6.3 megapixels camera and on the image with increased resolution. 2125 LWPH for the original image, 2146 LWPH for the high-res image. The detail is exactly the same, and it cannot be otherwise. Super resolution cannot invent missing information out of thin air. That said, super resolution does indeed perform better interpolation than other methods already available, like bicubic, bilinear, or preserve details to 0.0. The advantage in this example is clear. The connector pins are more engraved. The letters are more legible, and all components generally look better. This is a comparison between super resolution and the simply enlarged detail, without interpolation. Super resolution reconstructed the details convincingly, while preserving the texture very well. Super resolution technology also works well with black and white. The weak point is the cleanliness of the original image. Since super resolution attempts to reconstruct every detail, it also reconstructs and amplifies any imperfections, artifacts, and grain that may already be present in the original. Let's conclude with an assessment of file size. The increase in resolution leads to a much more than proportional increase in file size. For example, this 6.5 megabytes RAW file became an approximately 80 megabytes DNG file, while this 35 megabytes RAW file became an approximately 445 megabytes DNG file, with an increase of a factor of about 12 in both cases,